Okay, this is chapter 5, section 5, equilibrium in 3D of a rigid body. So we have a uniform plate. So what does I mean uniform? It means that your gravity center is in the middle. It's in the middle. It's at the centroid of your plate. So the centroid of a plate is there. So that's, I will call this point G. So I mean that the force, the weight, and we know the weight is given, it's 500. Is there. Okay, here we go. Okay, so your point G is in the middle of the 3 feet, and in the middle, and it's aligned with this. Oh, I should make it there. Should be aligned with this point. Move it a little bit. Here we go. Make more sense. Okay. So there's two given force. There's the weight, and also there's a force that is applied at this point. And let me give some names. So it's A, B, C. Let me call this point D. That will be easier. Okay. And this one is at G. Now this plate is supported by 3 cables, so cable is only tension. So we have the 3 tension of the cable. We will call this one TA, this one TC, and this one TB. Okay, and we need to solve for TA, TB, and TC. Okay? So I will propose to use the sum of the forces. It's equal to 0 as a vector, and sum of the moment, it's equal to 0. Okay, and just to make it easy, so here we have like 3 forces that we don't know. They are all attached to a different hook. The forces that are given also are all a different hook. So I will use this point there, 0, for my equation of moment. So I will use the moment about the point O, this point there, the point O there. That is the origin of the axis. Okay, so and the moment, remember that the moment is equal to R cross product F from O to F, the force. So let's do the table and I need space. So I make it a little bit smaller just to have enough space for the table. Remember point. So first column is the point. I'll write it after. Second column is the vector position. Third column is the force. And last column is the moment. Okay, so point R from O to the force, to the point. Let's mark it to the point. The force and the moment. Okay, so first point. So we need to consider every point where there is a force on it. So we will consider the point B, C, A, G, and D. So 5. So we need to cut this table in 5. So let's say it's the middle. Let's put it this one. I make 5 rows for my 5 point, kind of equal row. Here we go. So point, we have A. Okay, and most of the time the question is, I have the point A there. Why do I call this point A? Because you can slide a force on its line of action. So that's the same thing that consider this point A and this point A. So we have the point A, B, and C. We have the point D and the point G. So we have 5 points to consider. So what we need is RO to the point. So ROA, ROB, ROC, ROD, and ROG. Okay, so ROA, let me zoom a little bit on that. ROA is this one. There. So it's 3 feet. Oh, I want to do that. ROA, it's equal to 3 feet, and it's on I at. On J at, sorry. 3J at. ROB, that this one, so it's 4 on I at, this one. C, so C, basically it's A plus B. So it's 4 I at plus 3 J at. D, it's, okay, let's don't make a mistake. It's 2 on I at plus 3 on J at. And G, it's in the middle, so 2 on I at and 1.5 on J at. Okay, take your time to check your vector position. That's too bad. That's too sad just to do a small mistake there, and it will change the answer of all your unknown. So what are the force at A? It's TA, and TA is on K. So TAK. At B, it's TBK. At C, it's TCK. D, it's minus 200 on K. And W is minus 500 on K. And now the moment, it's ROR, so it will be 3 J at cross product T A K. Okay, let's do my little triangle I J K plus I J K, oops, minus in this direction. Okay, so J cross K plus I, so it's equal to 3 TA I at. Here we have 4 I at cross TB K at. So I cross K minus J. So minus 4 TB on J at. This one, so we have 4 I at plus 3 J at cross TC K at. So I cross K it's minus, so it will be minus 4 TC on J at, and 3 and J cross K it's plus I, so 3 TC I at. Make pause on the video if you need to think again to the cross products, okay, because I'm going fast on that. D, so it's 2 I at plus 3 J at cross minus 200 K at. Okay, so I cross K minus J minus minus, so it's equal to 400 on J at and J cross K plus, so minus 600 on I at. Yes. And this one is 2 I at plus 1.5 J at cross minus 500 K at. I cross K minus J minus minus plus, so 1000 on J at, and 1.5 times, so J cross K, it's plus, so minus, because there's a minus, so minus 750 on I at. Sorry, let's make it so small. Okay, so now, this one is a little bit more complex than the previous one. Now, we will take everything, that's me there, and I will write right away the equation on I, J, and K. Okay, so let's me close, remove those little one. Okay, and I will. So everything in front of, okay, so for the force, equation of the force, everything is on, look, everything is on K, 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 and K. So my sum of the forces on Z is equal to 0, give TA plus TB plus TC minus 200 minus 500, it's equal to 0. So it's TA plus TB plus TC, it's equal to 700. Okay, and that's one equation. Here we go. Okay. Now on the equation of moment, if we look at what is in front of I at, we have this one on I at, this one on I at, this one, and this one. So let's write this equation. So sum of the moment about the point O on x is equal to 0. So we have 3 TA. I don't want to close. Okay, 3 TA plus 3 TC minus 600 minus 750 is equal to 0. So 3 TA plus 3 TC is equal to 1350. Second equation. How many unknown do we have? We have 3, TA, TB, and TC, so we need 3 equations. Now, how much equation do we have? 3. So that will be perfect. Now for moment on I at, on J at, so we have this one, this one, this one, and this one. And that's our equation, sum of the moment about O on Y is equal to 0. Okay, so for TB, minus minus 4 TC, this one, plus 400 plus 1000, it's equal to 0. And it gives us minus 4 TB minus 4 TC, it's equal to minus 1400. So let's write 4 TB plus 4 TC, it's equal to 1400. And you can divide by 4 if you want everywhere. It will be a round number. This one you can divide by 3 if you want. But now we have 3 equations. And in this equation, there's either 3 or 2 unknowns. That will be tricky to play with. So let's do a system of, let's use matrix. Okay, so that's the 3 equations. So I will have a matrix minus 1 time a matrix with what we know. So I will put in the first column everything in front of TA, on the second column everything in front of TB, and on the third column everything in front of TC. First row, this one, second row, this one, and third row, this one. So in front of TA, 1 TA plus 1 TB plus 1 TC, it's equal to 700. Second column, second row, we have 3 TA plus 0 TB plus 3 TC, it's equal to 1350. And 0 TA plus 4 TB plus 4 TC, it's equal to 1400. Let's use this in your matrix. So you go on second matrix. You need the 3 by 3 matrix. Edit. So 1, 1, 1, 1, 1, 1, 3, 0, 3, 0, 4, 4. And you need a second matrix, or you can use RREF if you prefer. And your matrix is 700, 1350, 14. Second quit, and after that you call your matrix in the main page. So second, you call the matrix that you just did, the first one, your inverse. So for me it's a matrix C, so it makes matrix C minus 1 time matrix D. Or you can use the RREF if you prefer. And what you find is TB. So the answer is 350, 250, and 100. Yeah, that's correct. Woohoo! So TA it's equal to 350 pound. TB it's equal to 250 pound, and TC it's equal to 100 pounds. And everything is related to each other. So if you do a mistake to one equation, your 3 answers will be wrong. if you find something negative, you did a mistake somewhere because the tension cannot be in the other direction. A cable always pull on an object, cannot push. So that was the step. Oops, I went too much on the right. But that's the step for solving this problem. Oops. So first step, free body diagram. Second step, the table. Third step, the equation of equilibrium. And fourth step, solve. And here we go. That's it for this problem. See you in the next and last example. Bye bye.